Hello, JupyterCon. It's so great to be joining you virtually today. My name is Brad, and I'm joined by my colleague Tahir. We both work on the Google Cloud team, and we spend a lot of time working with Apache Spark. So today we're going to tell you a bit about Apache Spark 3.0, as well as how to use it for big data analytics with GPUs and Jupyter. So to give you an overview of the topics we're going to be discussing today, we're going to start by introducing Apache Spark, telling you what it is and some history of it. We're then going to introduce what's new in Apache Spark 3.0. We'll then go into GPUs and machine learning, followed by Spark and Jupyter, and then a demo showing how you can tie all of this together. So with that, let's just dive right in. So the history of data processing spans back much further than this timeline, but we'll start in 2004 with the introduction of MapReduce, which is a framework for doing parallel processing of data across multiple different machines. So this was a pretty big deal at the time, followed up in 2006 by Apache Hadoop, which allowed you to then store your data across multiple machines. And together between MapReduce and Hadoop, we really saw a lot of awesome parallel processing computational power and different infrastructures come into play. And then in 2012, we saw Hadoop Yarn was introduced, which created a new resource manager for actually doing this MapReduce and Hadoop jobs. And this allowed you to scale Hadoop across even more machines than you previously could. And the thing about all of these is while they were great, most of the computation, would happen with a lot of I/O and reading and writing to disk. And so where Apache Spark came in 2014 was a set of tools that allowed you to do all of the data processing in memory. And for fairly obvious reasons, this would allow you to reduce a lot of the issues that would come with writing to disk. So Apache Spark came out in 2014. In 2016, Spark 2.0 was released, which came with a new set of APIs, as well as new ways to actually store your data in memory that were even more efficient. So a lot of these changes happened on the API level, and they were really great. But then just this past June, Spark 3.0 was released, where a lot of the optimizations actually came underneath the hood. So we didn't really have too many API changes, but you saw a lot of speed up happening with the Apache Spark engine, which we'll talk a little bit more about. So taken from the Apache Spark website, Spark is a unified analytics engine for large-scale data processing. It's open source. As I mentioned, all of the data processing happens in memory. It's distributed, and it allows you to do the data processing in parallel. There's a really rich ecosystem surrounding Apache Spark at this point, given how long it's been around, and a lot of different open source tooling has been built on top of it, both in terms of the core library and also things that folks in the community have worked on. There's currently APIs supported in 4 different languages. Those are Python, Java, Scala, and R. And one of my favorite things about Apache Spark is the fact that the parallelization is actually almost entirely abstracted away from the user in terms of managing resources across the different workers and whatnot. You really get the benefits of just having to worry about the code and the actual transformations on your data that you're doing. So I mentioned worker before. So Apache Spark works with a master worker framework. So the idea here is that you start out, if we look in the top left, with your driver. This is where your Spark context or the actual point of communication that the user will have with Spark will be located. And from here, you can submit your Apache Spark jobs to the master node, which we can also call the cluster manager. And it's from here that the cluster manager will be able to figure out where all of your data and all of the transformations should actually happen across your cluster. So this will be split across a series of different workers, each of which will have a Spark executor with multiple tasks. So each one of these workers can be working on multiple different stages of the pipeline at the same time. And since Spark is evaluated lazily, the Spark processing engine is actually able to take all of the steps that you want to have happen on your data and figure out the most optimal way to do that before it sends the tasks out to the different workers. So in terms of how your data is actually stored in memory, there's 2 different ways that Spark can do this. So the first is with something called an RDD, or a resilient distributed data set, which is effectively just an unstructured set of data. You can load your data in as is, and then Spark will be able to keep track how the data is distributed across the different worker nodes. And then I mentioned in Spark 2 that there was the introduction of a new way to have your data be managed in memory, and that's with a data frame. And so a data frame, the experience of using a Spark data frame will actually be very similar if anyone's used a Pandas data frame before, in that it's tabular and structured, and you can actually add a schema to this, which makes processing the data much more efficient, since Spark doesn't have to guess what this data might be. So here's just a small snippet of code showing how you can get started with Spark. So here we create a Spark session, which is the pointer in memory to your Spark cluster, and then we can use this reference to load in data. In this case, we're loading in a CSV file, and we're inferring the schema. You can pass in a custom schema yourself. You can sort of do either one depending on your use case. And then here we have a small example where we are doing the Spark operation where pulling the data where the age is greater than 21, and then selecting the first name of all of these remaining rows. And then .show will print the data out to your console or to standard out, depending on where you're using this. So Spark supports reading in data from, at this point, almost all of the commonly used data sources. So of course, you have your CSV, JSON, Parquet, and Avro. There's also support for blob stores such as GCS and S3 and the like. Of course, HDFS, given that this came about following Hadoop, this is really one of the most popular use cases of using Apache Spark. You also have Iceberg, Delta Lake, and then as well several popular data warehouses, including BigQuery and Snowflake, and of course connectors that will support these sorts of integrations. So I mentioned that Spark has a really rich ecosystem, and we'll talk about some of the ones that are actually built right into the core Spark library. So here you'll see Spark SQL, Spark Streaming, MLlib, and GraphX. So let's talk about a couple of these. So Spark SQL allows you to actually interact with your data using SQL syntax, and allows you to then also perform Spark operations on the same data. So if we look at the code sample here that we have provided, which has been derived from the Spark documentation, we can read in a set of data. In this case, it will be a CSV file from Google Cloud Storage. We can then register a temp table by the name of people, and then perform SQL operations on it, referencing this table. But then you'll also see that we're then performing a Spark operation or a map operation on top of this same set of data. So it really gives you the flexibility to use whichever you may be more comfortable with, or what might be most efficient given your use case. Next up, we have Spark Streaming, which allows you to do processing on streaming data. You can set up a stream and then perform Spark operations on it. So in this case, we have a text stream that we're then performing a flat map, a map, and then a reduce by key on. And so this is a really popular feature that's baked into the library. So next we'll talk about Spark MLlib, which for anyone who's used Python scikit-learn before, the user experience is actually going to be very similar, and that this library provides estimators, transformers, and pipelines. And these all allow you to do machine learning, but utilizing the parallel processing power of Apache Spark. There's also a set of open source libraries such as Spark NLP that will augment Spark MLlib for more specific tasks, such as natural language processing. And so we can actually see on the right here, we have just a brief code sample of doing natural language processing using Apache Spark and Spark MLlib. So here you're seeing we're tokenizing the data, we're hashing it, and then doing a logistic regression model. And we can feed all of these into a pipeline and then train it on a set of Spark data that we're loading onto our Spark cluster. And then in terms of the runtimes for Apache Spark, so there's, I'll say 4.5, if you will. So there's the 4 we have listed here, which include Spark standalone, which allows you to just run your Spark cluster anywhere using the resource management that Spark itself can provide. You can also take advantage of Apache Yarn, which is what Hadoop is based off of. So this is also a very popular way to do Apache Spark. Spark runs on top of Mesos, and it also runs on top of Kubernetes. And there's a lot of active development happening here, especially in the Kubernetes world. Spark also provides its own web UI. And so this really allows you to get an in-depth understanding of what's happening with your Spark jobs. So you can see this happening at the different stage levels. So as I mentioned, Spark will create a plan for how it's going to operate each set of the transformations that you want. So using the web UI, you can actually see what these are and get an idea for what's happening underneath the hood, as well as if your jobs were successful or how some of the resources that were being used on your cluster, such as your CPUs and your RAM, being able to optimize and see how efficient these jobs end up running. And so there's a lot of really awesome things you can learn by taking a look at the web UI provided by Spark. Okay, so now that we talked about Spark generally, let's just spend a little time talking about what's new in Apache Spark 3.0. So I mentioned again earlier that Spark 2 came with a lot of changes to the API. Well, where Spark 3 really shines is that a lot of the changes happened underneath the hood to increase performance. So you have, to just talk about a couple things here that were done to be able to support this, we can start by talking about adaptive queries. So I mentioned that Spark creates a query plan when you end up sending a job, and it figures out what it feels is the best way to actually execute the tasks that you are requested. So in Spark 3.0, this is actually now adaptive. So in the middle of actually doing the processing, if Spark identifies a potential increase or a potential optimization, it can make the change on the fly, which will then end up resulting in less resources being used and less time to complete the transformations. There's also a dynamic partition pruning, which allows Spark to somewhat rearrange the order that you might have requested some of the transformations, such as doing a filter on multiple different tables. So this really provides a large speed up in terms of less data being processed if it's able to figure out the best way to speed up these the requested transformations and data loads. And then last, but certainly not least, is GPU acceleration. So historically, Spark really shined just using CPUs and memory, but now you can actually use GPUs as first-class resources with Apache Spark. And this is due to a lot of awesome work that's been happening with NVIDIA. That's been continuing to work with the Spark community to bring GPUs into Spark native processing. And then, of course, there's many enhancements and additions to Spark and Kubernetes. As I mentioned, there's been a lot of active development happening here as well. So speaking of GPUs and machine learning, let's talk about this a little bit. So everyone who is currently watching this presentation is doing it from a device that has a CPU on it, or a central processing unit. I'm sure we're mostly familiar with how this works, but the idea is that CPUs were designed to do general purpose processing, and that they're designed for a wide variety of use cases. And of course, most machines nowadays come with multiple CPUs in them, dual core, quad core, octa core, what have you. So they're really great, but because of their wide variety of use cases, there's some things that they can certainly do better than others. And where they actually can fall flat in terms of, especially as compared to newer advances in hardware, is in doing some forms of data processing, in particular, matrix-based calculations. And so that's where GPUs really come into play and are able to just perform much better than CPUs can here, since they are designed for the parallel processing of information, again, in particular matrices and other mathematical computations. They've been really widely used in terms of doing machine learning. And so now that GPUs can be used with Spark, this really pushes what we're able to do with machine learning, but also in terms of just general data processing too. NVIDIA has done a lot of awesome work here to create these optimizations, such that if you have GPUs available, a tool that they've been working on called the Rapid SQL Accelerator will actually figure out how to optimize your transformations without you needing to do any extra setup. And so Spark and machine learning come with a wide range of tools that you can integrate into your machine learning workflows. So we already talked about Spark MLlib, but next we'll talk about MLflow, which is a tool for managing the entire machine learning lifecycle, including things that might utilize, or workloads that might utilize Apache Spark. So you can utilize MLflow. You can also utilize TensorFlow. There's tools for running TensorFlow jobs on top of Apache Spark. a cool tool that I've been playing around with recently is called the Spark TensorFlow distributor, which is actually a wrapper for the TensorFlow distributed libraries and let you run distributed TensorFlow jobs directly on top of Apache Spark. And in combination with GPU support, this results in really fast training times. So I'm really excited to see this piece sort of develop. You also have access to XGBoost with Apache Spark and GPUs, and a lot of the work here has been occurring with the NVIDIA team as well as the NVIDIA Rapids team. And then I keep mentioning Rapids. Of course, we can talk about this too in terms of being able to run Rapids jobs on top of Apache Spark utilizing GPUs. So of course, we are here at JupyterCon. So let's talk about how you can actually use Spark and Jupyter Notebooks together. So Jupyter supports a wide range of tooling that makes using Apache Spark with it super easy to use and just makes sense. So you can start off by installing a Jupyter Notebook either locally or on your Spark masternode, depending on your use case. There's multiple different kernels available for this. So you can choose between PySpark and Spark R, which are the Python and R Spark runtimes respectively, as well as the Spylon kernel, which allows you to actually do Scala using Jupyter Notebooks. And so you can leverage Apache Spark in any one of these. You also have access to Jupyter Magics in the form of Spark SQL Magics, which lets you run just native SQL code in your notebooks on some of your Spark data frames. And then you also have access to the monitoring features that I talked about earlier. You can access certain pieces of the Spark UI from your Jupyter Notebook itself. And so speaking of Jupyter Notebooks, I'm going to now pass this off to Tahir, who will give you a demo and show you how all of this stuff sort of works together. So Tahir, take it away.
Thanks, Brad, for the great overview of Spark and setting the stage for how Spark can be used with Jupyter Notebooks. So for the demo, I have a 3-node Spark cluster running on Dataproc on Google Cloud, and I'm using a Jupyter Lab instance, which is running on the main node of the cluster. To start off with, you can see that you have 4 different types of kernels you can use. You have a Python 3 kernel, PySpark kernel, R kernel, and Spylon kernel. The Spylon kernel is used for Scala code, which is really popular in the Spark community, as Spark is created using Scala. R, which is used for Spark R, and then you have 2 for Python, the PySpark kernel and the Python 3 kernel. I'll be using a Python 3 kernel, as this allows you to modify a Spark session from within the notebook, which is really useful if you want to add packages that might not be installed on the cluster, or to change Spark configurations specifically for your application. I will actually go and open and run through a notebook I created earlier, which will go through some tips and tricks that I hope will be useful for any Spark and Jupyter Lab users. In my notebook, I start off by creating a Spark session, and I'm including some packages that will be used later on in the notebook. I always like to print out the Spark version number just to check I'm using the right version, especially if I'm looking to make use of new features in Spark 3.0. I've also printed out the Spark application ID, which will come in use later. In terms of using Spark, you have a few APIs that you can use, and I hope that if you already use Pandas, picking up Spark will be easy for you. Just to show the comparison, I'll run some Pandas code that will read a Parquet file into a Pandas data frame, do a group by, and some aggregation. Let's look at the equivalent code using the Spark Dataframe API. As you can see, it's not that different. However, if you do like using the Pandas Dataframe API, but want the power of Apache Spark, then there's a new project that has been created by Databricks called Koalas, that allows you to use the Pandas Dataframe API to execute your Spark code so that you get the best of both worlds. To use Koalas, you just need to pip install the package and then you're ready to go. Let's take the original Pandas code and just replace Pandas with Koalas and run that. The code now executes using Spark, and we just had to change one thing. Spark also allows you to write SQL queries, and behind the scenes, the job will be executed in exactly the same way as if you're using the Spark Dataframe API. I can convert the same example into a SQL query and run that, and you should see that it will have exactly the same results. So that's a few ways to get started with the various Spark APIs, and this shows you that unlike some other big data processing frameworks, Spark is a great tool even for interactive analysis. If you're a heavy Jupyter user, you probably want to know about what magics are available for Spark users. If you write SQL queries, you probably want something that's more user-friendly than the spark.sql code I was using above. So there are a few options for Spark SQL magics that I've listed here. The first option supports the Livy protocol that Brad mentioned before, which is useful if your notebook is not running on the Spark cluster. The second one is a package I found on GitHub that works well for our use case, but I'm actually going to use the third option for this demo, just so that you can see the code behind the magics being created. These were created and shared by someone called Luca, who works at CERN. The Spark Explain magic lets you see the query execution plan, which is useful for debugging before running a query. Spark SQL will run your query and give you the output, but as you can see, it's not in a great format, which is exactly why we have SQL display, which converts the Spark data frame into a Pandas data frame. What if you want to see the performance of your job though? Then you're probably familiar with using something like the time or timeit magic, which is great for Python code, but it won't tell you much about your actual Spark job. For this, there are two options that I use. The first one is Spark Measure, which you can install on your cluster, which you might have seen me doing at the beginning when I created my Spark session, where I included the Spark Measure package. And to get it to work with Python, you also need to pip install the Spark Measure Python package. Once that is done, you can create a new magic that shows you the stats of your Spark job once it's completed. However, if you want to see the status of jobs while they're running, you will probably want to take a look at the Spark UI. I created my own magic called Spark UI that lets me embed the Spark UI right into JupyterLab above the Spark code I'm running. This way I can easily see how things are going as the job is running, and this is now one of my favorite ways to debug and analyze my jobs right next to my code in a notebook. Next up in the demo, I want to show how you can plot Spark data frames. The trick is to convert the Spark data frames into a Pandas data frame. Before you do that, however, I recommend that you enable Apache Arrow, which massively improves the speed of the conversion. In this example, you can see converting 100,000 rows went from 10 seconds to about 3 seconds. Following that, you can continue to use any Python plotting libraries and visualize your data. To end, I want to show you an example for running Spark ML. So here you can create a Spark ML pipeline, which allows you to do your pre-processing and training and evaluation all in one pipeline. And you can see your predictions and evaluate your model right from a notebook. So I hope this demo was useful and you learned a few tips and tricks, and look forward to seeing what other people do with Apache Spark and Jupyter Notebooks.
Awesome. Thanks to hear. So just to sum up what we talked about today, so you were introduced to the Apache Spark and we discussed sort of what it is, how it came to be, and some of the things that you can do with it, and what's new with Apache Spark 3.0. We then talked about GPUs and machine learning and how these integrate nicely with Apache Spark. We then talked about how Spark and Jupyter works together, and then Tahir showed you an awesome demo of actually doing this and some of the other cool things that you can do with Spark and Jupyter Notebooks. So that's all we have today. Thank you so much for tuning in. I've included myself and mine into here's Twitter handles. So if you have any questions, please feel free to reach out to us. And the link to the Apache Spark website is shown here. It's just spark.apache.org. So go ahead and get started, and super excited to see what everyone does with this. Awesome. Thank you, everyone.